Hi, my name is Delaram Golpayegani. I'm a PhD researcher based in Dav Centre, Trinity College Dublin. In this video, I'll present our work in development of an ontology called AIRO that represents risk of AI systems based on the EU's AI Act proposal and ISO 31000 series of standards on risk management. There are quite a lot of AI incidents documented and reported. Just by spending a little bit of time exploring AI incident repositories like the AI Incident Database and AIAAC repository, it becomes clear that in some cases use of AI caused more harm than good. AI systems made biased decisions, invaded privacy of people, distorted human behavior, and caused major irreversible damage to individuals. Well, many agree that use of AI involves risk, but the question is how to address the risk associated with the use of AI systems. There are activities undertaken all around the world, especially in Europe, to promote trustworthy development and use of AI systems. The most important one is the European Commission's proposal for AI regulation called the AI Act. The basis of the AI Act is a risk pyramid that classifies AI systems into 4 categories based on their risk they impose to 3 main areas: health, safety, and rights of individuals. Most of the regulatory obligations of the AI Act concern high-risk AI systems. The first step for providers of AI systems is to determine whether their systems are high risk or not based on Annex 2 and Annex 3 of the AI Act. Annex 2 is basically a list of already regulated areas, and Annex 3 lists high risk uses of AI in different contexts. We structured Annex 3 conditions into 6 concepts, namely domain, purpose, AI application, AI user, AI subject, and environment of use. We also have a concept for AI technique, which is used to determine if the system is an AI system according to the definition of the AI Act. Based on a combination of these concepts, we can decide whether a system is high risk or not. We also identify the information that AI providers need to maintain and share with authorities according to Annex 4, which describes the technical documentation. You can see AIRO's key concepts and relations here. The upper half, the green boxes, represent concepts related to AI system. For example, its purpose, the techniques that are used in the system, its users, developers, and so on. Most of these concepts are extracted from the AI Act. In the lower half, the green boxes show concepts related to risk. For example, risk source, consequence, and impact. These concepts are extracted from ISO 31000 family of standard on risk management. Risk can be related to AI system or its components, and this can be modeled using has-risk relation. As I mentioned before, these are just the key concepts of AIRO. To see all the concepts and relations, you can visit w3id.org/AIRO. For evaluation, we used AIRO to model real-world use cases, including Uber's real-time ID check system and Virgin domestic wireless system. Then we run a Sparkle query. Sparkle is a query language for RDF graphs to retrieve the 6 concepts for identification of high-risk AI systems. To automate this process, we use Shackle to write rules to determine whether an AI system satisfies conditions for being high risk. As I just discussed, AIRO can be used by organizations for determining high-risk AI and generating technical documentation. Researchers can expand AIRO to create domain-specific AI risk ontologies and annotate existing AI incidents. Authorities, standardization bodies, and certification bodies can also benefit from AIRO. Thanks so much for coming this far. Again, you can explore the ontology at w3id.org/AIRO. Also, you can take a look at our recently published paper on this subject. Thanks again.